Where does that term noble gases come from? Are they nobility? Do they rush to rescue maidens?
No, you're thinking of heroes. They're like nobility in the sense that they don't mix with the riffraff. They don't like to react with any other elements. By and large, it's not possible to form compounds with them.
Well, it's a shame for your collection that they're gases, because you've got big blanks here. Oh, ho, ho, ho. The noble gases, like neon and argon, pose a problem for chemists who prefer their elements to join forces and react with each other. You can run an electric current through them, excite their electrons, and get pretty colors, which is how neon lights work. But the noble gases don't react. They pretty much refuse to combine with other elements.
Being an inert gas, being unwilling to mix with the other elements, react with them, this is a very clear-cut distinction that sets apart this particular column from all the others in the periodic table.
So why are these guys so aloof? As it turns out, protons may determine the identity of an element, but electrons rule its reactivity. And reactivity is a shell game. Here's how the game is played. Imagine that these balls are electrons, and the target is an atom. Electrons don't just pile on around the nucleus. As with skee-ball, where you land relative to the center counts.
Oh, come on!
The electrons take up positions in what can be thought of as concentric shells. The first shell maxes out at just 2 electrons. The next holds 8, then it goes up to 18. An atom with 8 electrons in its outer shell makes one happy, satisfied atom. And noble gases come pre-equipped with completely satisfied shells. And is this the only column like that?
It's the only column where all the shells are completely filled.
But what about the column just before those stable noble gases? They're called the halogens. They have an outer shell that needs just one more electron to be full, and they'll grab it any way they can. The group includes fluorine and bromine, but the most notorious is chlorine. 17 protons surrounded by 17 electrons, arranged in 3 shells of 2, 8, and 7, one short of being full. It's that extra electron chlorine will get any way it can, sometimes with violent results. That's why chlorine gas was used as a deadly poison in World War I.
Chlorine, I mean, this is nasty stuff. This will take electrons from kittens. You know, it'll go and steal an electron off the water in your lungs and turn it to hydrochloric acid because it really wants an electron.
Yeah, maybe I'll leave that where it was.
Now, if you go the other direction, you end up with the alkali metals.
The alkali metals are the first column. Each of them has full shells plus one extra electron sitting in a new outer shell. They have familiar names like lithium, sodium, and potassium. And they all want to get rid of that single lonely electron any way they can.